up on the board we've got the three scenarios that are going to happen involving chords and secants and tangents with circles and their segment lengths that are created by these things. So the one here on the left involves two chords intersecting inside. And these could also be secants, if there were secant lines. If we're just focusing on the inside bit here, just this piece and this piece and this piece and this piece. We're all going from the edge of the circle to the point where the two chords intersect. So A is that little piece, C is the remainder of that chord, D is that little piece, and B is the remainder of that chord. Okay. When two chords intersect inside the circle, the product of the pieces of one chord equals the product of the pieces of the other chord. So particularly A times C is equal to B times D. The product of these two pieces equals the product of those two pieces. Okay. So that is the property we'll use for that picture. Moving along to two secants, and we have the outside part and then the inside part. So A is the distance from the point of intersection of the secants to the edge of the circle, that's A. B is the length of the chord inside the circle all the way to here. And C is the distance from the point of intersection of the two secants to the edge of the circle. And D is the length of the entire chord inside the circle. Okay, the relationship in this picture is the outside part, which is A, times the entire length of the secant from the point of intersection all the way to the back end of the circle, A plus B, equals the outside part C times the length of the entire secant from the point of intersection all the way to the edge of circle, C plus D. Outside piece times entire piece equals outside piece times entire piece. And finally, over here, we have a tangent and a secant. Okay. The tangent has just from here to the point of tangency. And the secant has the outside part from here where the tangent and secant intersect to the edge of the circle. That's A. And then the entire piece, B is the chord, so B goes from here to here. So the relationship between a tangent and a secant in this relationship is the tangent squared equals the outside piece times the entire piece. So each of these rules, secants have the same picture every time. The outside piece times the entire piece, that's how the secants work. Tangents are squared, and then two chords intersecting, the product of the pieces of one chord equal the product of the pieces of the other chord. So you should commit these to memory. Pretty straightforward rules. They're always these. They don't change their mind at some point. So moving right along to example 1, we need to notice that they're talking about segment lengths, not angle measures. So we have our angle measure rules we learned last week. Now we got our segment measure rules that we're dealing with this week. These are two chords. AC is a chord, BD is a chord. The distance from A to the point of intersection, which I'll call that point E, from A to E is 5, from E to C is 6, from B to E is 4, and from E to D is X. And this is what's the value of X. So I see two chords intersecting. The relationship in that picture is product of the pieces of this chord equals the product of the pieces of that chord. So it'll be 4 times X is equal to 5 times 6. So we apply the rule. We carry out the multiplication. 4 times X, of course, is just 4X. 5 times 6, of course, is 30. And if 4X equals 30, we divide both sides by 4. 15 over 2, 7.5, 7.5, one of those answers. I'm fine with 7.5.